Hi everyone, welcome to this video going over lesson 21, perfect squares and perfect cubes. A perfect square is a product of a number multiplied by itself. So let's say we take a number x and we multiply it by itself. X times x gives us x squared. And so any number multiplied by itself, the answer is known as a perfect square. And so in part A, we are going to start to make a list of our first 12 perfect squares, because these are numbers that I want you to have memorized. They're going to be important for what we do in this chapter. So let's start with 1 squared. 1 squared is 1 times 1, which equals 1. Next is 2 squared. 2 squared means 2 times 2, which is 4. So 1's a perfect square. 4 is a perfect square. Next we have 3 squared. 3 times squared is 3 times 3, which is 9. 9 is a perfect square. Next we have 4 squared. 4 times 4, which is 16. 16 is a perfect square. Next we have 5 squared. 5 times 5, which is 25. 25 is a perfect square. Next we have 6 squared. 6 times 6, which is 36. 36 is a perfect square. Next we have 7 squared. 7 times 7 is 49. 49 is a perfect square. Next we have 8 squared. 8 times 8, which is 64. 64 is a perfect square. Next we have 9 squared. 9 times 9 is 81. 81 is a perfect square. We're almost done. 10 squared. 10 times 10 is 100. 100 is a perfect square. Then we have 11 squared. 11 times 11 is 121. And lastly, 12 squared. 12 times 12 is 144. So I want you to start to memorize these. If I say what is 4 squared or what is 8 squared, you should be able to tell me that product. The reason we want to have our perfect squares memorized is because we are going to start to talk about radical expressions. A radical expression we've seen before. A radical is the opposite of an exponent. So this n out here is known as my root index. And if I were to rewrite this, this is asking for what exponent n for b will I get a. So for instance, if I put 36 and the root index 2, this is asking what value when squared will get me 36. So what value times itself will get me 36? And the answer would be 6, because 6 squared is 36. And so we are first going to talk about square roots. And when we take a square root, we actually don't write the number. Whenever you see just a radical and there's no root index, it's assumed to be 2. So a radical is asking what number times itself will get me the number on the inside. And so we just answered part A. The square root of 36 is 6. And basically what we are doing is we are going backwards. So for instance, the square root of 36 was 6, because 6 squared is 36. So in part B, it says what is the square root of 16? So I'm going to locate 16. And the square root of 16 is 4. Because 4 times 4 is 16. The square root of 9 is 3, because 3 times 3 is 9. The square root of 100 is 10, because 10 times 10 is 100. The square root of 64 is 8, because 8 times 8 is 64. And the square root of 25 is 5, because 5 times 5 is 25. So those are square roots. A cube root has the root index of 3, and it's asking what value multiplied by itself 3 times will get the number on the inside. So for example, I want to know what number times itself 3 times will get me 8. And that number is 2. 2 times 2 times 2 gets me 8. So just like what we did with our perfect squares, I want to come up with a list of perfect cubes, the first 10. So 1 cubed, 1 times 1 times 1 is 1. 1 is a perfect cube. 2 cubed is 2 times 2 times 2, which is 8. 8 is a perfect cube. Next we have 3 cubed, so 3 times 3 times 3, which is 27. 27 is a perfect cube. Then we have 4 cubed, 4 times 4 times 4, which is 64. Next we have 5 cubed, which is 5 times 5 times 5, which is 125. Next we have 6 cubed, so 6 times 6 times 6, which is 216. Next we have 7 cubed, so 7 times 7 times 7, which is 343. Next we have 8 cubed, so 8 times 8 times 8, which is 512. Next we have 9 cubed, so 9 times 9 times 9, which is 729. And lastly 10 cubed, so 10 times 10 times 10, which is 1,000. So 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1,000 are all perfect cubes. And if we were to find the cube root of any of these numbers, we would essentially be going backwards. So in part A, it asks, what number times itself 3 times is 729? And so I'm going to look at my chart and find 729, and that's the result of 9 cubed. So the cube root of 729 is 9. Next I have the cube root of 216. That is asking what number multiplied by itself 3 times is 216, and that is 6. Next I have the cube root of 8. So locating 8, I see that 2 times 2 times 2 is 8. Next I have 64. I get 64 by multiplying 4 by itself 3 times. Next I have the cube root of 1. I know that the only way to get 1 is by multiplying by itself 3 times. And lastly 125 I get from multiplying 5 by itself 3 times. And so those are my perfect squares and perfect cubes. We call them perfect squares and perfect cubes because when I find the square root or the cube root of these numbers, my number is perfect, which means notice how I got 9, 6, 2, 4, 1, 5. None of those were a decimal because there exists a number that when multiplied by itself 2 times or 3 times gets me the number on the inside. What we're going to see in the next video is what happens when we try to take the square root of a number that is not a perfect square. So please let me know if you have any questions and start memorizing those perfect squares and perfect cubes. I will see you in class.